Okay, I think it's time for us. I hope everybody's back. So, this here is the file that I gave you. Thank you. So this is the file that you have downloaded. It's called the 3804 CNC last name, first name, student ID. Guess what you have to do with this first? Yes, you put your, when you save it, last name, first name, student ID. So that's a very good thing to kind of like hand in your thing with the correct title of the naming of the file. So when you are finishing with your student file that I gave you, which looks like this, and you save it, then you save it as SM3804 underscore CNScore underscore, and now we ask money. So what would you write here? Last name? Huh? And then first name, money, and then student ID 1, 2, 3, 4, 7, 8, 9, 10, 7, and then dot 3M. So when you save it, please don't save it as CNC last name, first name, student ID. Use yours. In this file, you see on top view, on the top view, we see two little diagrams. One is describing the tool, these are in section, and the material here. And it basically makes you aware that the limitation in this file is that we have a 3-axis CNC milling machine. For 3 degrees of freedom, not 5 degrees of freedom, not 20 degrees of freedom, okay? 3-axis CNC, X, Y, Z. Our tool can go up and down, left and right, and back and forth, which I can't show you in the section. It cannot rotate. So our tool in this exercise cannot do something like this. It cannot do this, okay? Cannot. That means our tool can only go okay, and obviously to the back as well. Yeah. Which means if you're making a geometry that looks like this, then our tool cannot go and reach any of the red marked area. So if you're making a design that has overhangs for undercuts, our 3 degrees of freedom CNC machine for this exercise cannot reach it. Cannot reach it means you made a mistake, means one of your 5 points is deducted. Okay? If your hexagonal tile does not match at each side with each side, this is our hexagonal tile. It has 6 edges. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Hexagonal tile. In this exercise, no matter how I rotate it, here's A, B, C. Here's A, B, C. Here's C, A, B. Here's B, C, A. Here's C, A, B. No matter how, it needs to be continuous. Of course, it's very easy if you have no curves. Haha, of course it's continuous. So very funny. Okay? So in the end, what you will need to do is to hand me this in, and under this template, I want to have yours. A single one and the rotation as shown. A, B, C, C, A, B, B, A, C, etc. Okay? Got it? Good. Lovely. Now I'll show you a couple of potential candidates, and you can then decide which one you will go for, and I will demonstrate it. This is the same that you have. It is a hexagonal with a distance of 125 units edge distance. Calculate that yourself with the command distance if you don't believe me. It's 125 and it's 50 millimeters deep. Yours is distance endpoint to endpoint 125 millimeters and 50 millimeters deep. This means I don't want any file, any part that is bigger than 50 millimeters deep and 125 by 125. So it means the bounding box is this. Nothing can be bigger than this. Yes? I hope you understand what I mean. If your tile in the end at any given point, is higher than 50 millimeters, that's another point deducted. So it means your tile has to fit into this tile here. Okay. So let's start. If we are saying it fits into my tile, I can obviously make, for instance, a line using the near snap points anywhere here. So, and most likely I want this perpendicular. So it means horizontal, perpendicular. You can put this line wherever you want. You can put it very high up or very low down. Obviously very, very high up will give you only very little room to play. Or very low down would be nice. At some point it will get low, maybe too little. I can use my polyline and the perpendicular snapping towards all these cases. So I have now a datum. Datum means I have a line that is at all points the same around my boundary box, my bounding element. Okay? Now remember, we can make another line, for instance, for the top surface. Yeah, or you can just take what we had here, join it, and copy it vertical. One element to the next element. Or you just draw it around if you feel like it. Now I suggest that within the upper limit and the lower limit is where you are making your design. Okay? And remember, in our lecture, one of the best examples, or the example I showed directly, was a 2 ridge, 3 valley example. Valley, 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 ridge, ridge. Okay? Now if we look at that, then we can explode our hexagonal here. So now we have a line here. If we would say we have 2 ridges in this design that are equally spaced, then we can divide D-I-V-I-D-E, this line into some 3 equal elements. 3. Now I have 2 points on this line that are equally spaced, correct? Now I could draw a line. It could be a straight line, or it could be a non-straight line. It's up to us. One of the important points here to make is though that we need a valley point here as well that is equally everywhere the same. So explode. And here we could then divide this line into 2 elements. That will give us the midpoint. Now I can use a straight line or a curved line. I will do this with a straight line first. I can go with the straight line and snap to the point. So I would have to put my point snap on, which is here, and near point. I can go to this point, and to this point, and to this point, and then to this point. Now what I've created is a total symmetrical edge conditions from left to right or from right to left. It has one middle point in the middle, has a valley, and two valleys on its outer part, right? There's a valley here, and a valley here, and a ridge here, and a ridge here, which is very similar to here. We have a valley, and a valley, and a ridge, and a valley, and a ridge, and a valley. Okay? Yeah, is that clear so far? Look at it as well here. We have a valley, a ridge, a valley, ridge, valley, blah, blah, blah. Same. Ours is much easier. I can make this as well as a curved linear form. I can draw edge, valley, edge, valley, edge. We can do it as well like this. We could try to do it as well with our curve of interpolated point. It might, though, be a problem that it goes too high, but it might not. Oh, it looks good. Each of these curves is completely symmetrical, completely the same, right? This one, this one, this one. Let's start with the easiest one, which is clearly the element that is that we drew here. Now you can repeat the construction of what I just did for each side and waste some time, that's up to you, or you use a mirror command. With the mirror command, I can mirror it alongside the axes of the shape here. So it's fairly self-explanatory that if I use a mirror in a hexagon, then the points will always meet, and the element itself will mirror. So that was easy, right? So endpoint to endpoint, mirror, all good, happy day started. We're going to hide these for a moment. So I get now my edge condition of this element is everywhere the same. Good. So far, so good. Now we do have to, if we're imitating exactly what happened here, we'll have to combine two ridges over one field and two ridges over one edge, one point, one corner. So if we start with the easier one, so I'm going to explode now my block, my boundary block, and hide the top, maybe as well the sides for the moment because I don't need them. Then I see I have to connect this point with this point. Now if I just connect them straight like this, and this guy with this, I would have created the condition that you see here. Not very interesting just with a straight line, but it would be at least connected. Now, of course, if I draw a line from this corner that we made to this corner, then I have the middle point between those elements, and I could use my curve tool, point curve, or the interpolated curve, to basically select any point on this line here. So I could select this, and I could select this line. Okay? So these would be the straight lines, and these would be the curved lines. Okay, that was easy thus far. Now we have to do the same for making a condition between these elements here over one full field. Correct? So let's try to do that again. I'm hiding this. And if I make a straight line over one field, then it goes from this point to this point, and from this point to this point. Right? This will be our red lines, the straight lines. Again, not a very interesting point, but fine, not our problem. Now, if we are getting a little bit more excited with this, we would have again to make a middle point for our curve to be constructed. So we would have to find the midpoint on this element here, for which we need to switch on the midpoint in the snap. Then we can snap to the midpoint here and snap to the midpoint here. Okay? That helps us now to use this command here for the interpolated curve from this point to anywhere here, to our point here, and from the second point to anywhere here, made a mistake, anywhere here to the second point. Right, now we have these two lines, which are, make them on green. Now I can choose to mirror them just so they would fit here and go to there, or I make two different ones. That's okay, because the edge condition stays the same. For the simplicity of the argument for the moment, I will simply mirror them, and I will show some more extreme versions in a moment. So here I mirror them, so now I have this is a ridge, 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 and this is a ridge. Which mimics exactly what we see here: two ridges, two valleys, two ridges, three valleys, two ridges, three valleys, over one field, and here over the edge. So we basically got all our ingredients now. I'm going to hide as well these folds now, HIDE. Okay? So now we should be able to see if we can combine this in an easy way. The first thing is to explode these polylines, because we don't want to extrude anything together, so explode. Okay, so now we could create a line between this, this, and this. Yep. Now we can use a loft command for that. Or we could use actually a two-rail command if we want to include this guy and this guy and this guy in one nice smooth move. So if we do a two-rail line, let's do the two-rail for this. So we can select this guy and this guy and this guy and this guy and join them. Join. Now there are two open curves. If you go to your selection of surfaces now, you will see we discussed the loft, and you can always do the loft here. Would not be such a problem, but it's easier to work with rails. So here you got sweep one rail or sweep two rails. If we go for the sweep two rail, we can select this. It looks a bit like the rail of a train. So one rail and the second rail. And then it says what are the sweep, and so I'm going for that one which we join to that one which we join. What you get is the perfect connection between those elements. All done. You say, okay, thank you very much. Done. Now we have this rail, this curve here, together with this element and this element. So these are three curves. And here we could use, for instance, our surface from 2, 3, or 4 edge curves. So if you select that, boom, you get that surface done as well. Hallelujah, that's easy, huh? 2 already done. And if you were smart, then you could repeat this command here. So let's do explode. And let's take this guy and join it. That will be our sweep curve. And we do the same here, explode. And we take the middle one, and we join them. And then we can select the same command. Sweep two rails. One rail, the second rail, one sweep, the second sweep. Done. Okay. And then here we now have a bigger problem, because here we have a quite complex arrangement between this curve and this curve. However, and we obviously still have to see what do we do with the next two sweep rails, because they're intersecting each other. So this is not going to be super easy. But you can always make it only with one ridge and one valley. So I'm giving you here the hardest option, and obviously you can decide to make it easier yourself. So let's do that here one more time. So we join these guys, and we join these guys. Okay, thus far all clear. Then we do our sweep two rails. One of the green rails, take one of the green rails, one of the black ones, one of the black ones, done. Now you see already that that will create problems here, for sure. because that we cannot see in Siemens. So we will have to decide which one is the dominant one and which one is the subservient one, so to speak. Well, we can do that later with the trimming. Let's focus a little bit onto this area here. So if we take our green curves here and here, and we would split them. So let's say we take this green curve and we split it with this green curve. That means we get this green curve is now only from this, from here to there. And we do the same with this, split with this. So now we got this curve, and then we have this curve and this curve. And that is 4. And we like 4 curves. 1, 2, 3, and 4. Ta-da! We got a surface here made from these clear surfaces. Okay? Fantastic. Now let's look a little bit at our friend here, which is a bit of a troublesome. So if we select them both and we trim TRIM, and it's very important to do apparent intersections no, we should be able to trim the mid part of this problem out, like so, and thus create a continuous surface here. Now, ladies and gentlemen, we're getting very close to finishing this here. We got this part, we got the double curve intersector here, we got the top part here, so we need to just repeat what we did with the green curve for this field and this field, in which case we only need to take the curve, split it with the second curve, split, and the second curve, split with the first curve. And then we can do again our curve by 4, surface by 4 curves. One is the split curve, the second one is the split curve, one is the corner curve, one is the second corner curve. Done. And if you're really, really lazy or smart, then you can mirror this, because the whole thing is anyway symmetric, to this side. Not bad, huh? So we're really getting there. We only have to fill this body and this body. And now here comes a very tricky conversation, because we got, it's a very problematic element, because we got 1 curve, 2 curves, 3 curves, 4, 5, 6, 7. So this is really hardcore difficult. So this we have to really think a little bit about how we're doing this. There's many options of how to do this. One of the options could be to make a line that goes from this part to here. Okay? But that way we could make actually a continuous curve from here to there. We could try to do something like this. It's not an easy game, and there's many other ways to do it, but this might be one of the ways. So here again we have a curve that's too long, so we split it with its secondary curve. Now we have this curve, and then we have 1 curve here and 1 curve here, which is 3. So we can make a surface by 3 curves. Okay, that works. Well done. Okay. The other thing we could do here, and that's a bit more tricky, we made this long line here where we had all the midpoints going through. So we can split that with the 2 lines here, one there and one there. So we have this middle part here. So what we could try to attempt, it might work, I'm not sure, we can join these 2 guys here, and we can use this green line that we split along that little part here, and this green line, which we split again along this line, and see if we can do a sweep to rail. So let's try. We take this part, and we take this part, and we are selecting this part, and we select this joint part. And it worked. Look at us. Not bad, huh? So we made the same command. Now we could decide, if we really want to do something crazy, why don't we keep one side and the other side not symmetrical, because the edge condition is the same. Okay, let's do that. Fun fact. So here we can do our sweep to rail again, because we got 1 green light here, and then we should have this which we drew ourselves. So that's 1 rail, 2 rail, 3 rail, 6 here, and 4 is here. Good. So let's do it again. 1 green here, 1 here, 1 that we just used, and 1 that we use here. Done. In fact, we could have done it what we before. Now if I Control Alt R, these are the rendered version of it. So that's quite neat. So now we can join this. Join this with this, with this, with this, with this, 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 this. Good. Now let's copy this out. And here we are. Looks pretty damn neat, I have to say. Now, if we try for one moment just to take this and copy it around. So I'm going to go and just test, does it work when we set it to. Okay? So I'm taking this and I'm copying this point to this point and to this point. And then I'm going to rotate this here, right, from here to there. And then I'm copying this and then I can rotate it one more. Oh, I see I made a mistake, I rotated it wrong. You have to be careful with these things. You make even the slightest mistake, it will not fit. And then I can copy this. Now it's rotated by 180. So you start to see already that we have an interesting pattern emerging here. Very nice, very nice. So it's completely continuous. Doesn't stop anywhere, and you're obviously losing very fast the idea of the rhomboid here, the hexagon being behind it. So the only thing that would be left to do here for us would be to close it into a nice solid object. So for that, we can use our tracer here, or we can join it, but we only need to go one down here, and then we can join this line with the edge condition here, with this line, with the edge condition here, with the edge condition here, with the edge condition here, with the edge condition here. That will make a closed line, and with this we can make our surface, which is the planar curved surface. There you go, already done. Now again, you can do this again and again and again, or you're being smart and use your mirror commands. You can be even ultra smart and mirror it over the whole field, because you have the midpoints, if you were clean. And here we can again mirror via the corner condition, as well as here via the corner condition. Then we can join everything up and copy it out. And here is your perfect element. This, if it all joins up into a closed solid, if you didn't make a single mistake, and you have 2 ridges and 3 valleys, then you get 5 points. That's it. If you choose to make a different design, we have different ones, of course. I will show you some different ones now that are easier, where you still can get 5 points, but the point here is, you have to work clean that it is a solid, closed object. If the edges don't meet and it's all open, that will be deducted in points. If you're going outside the 125 by edge lengths and 50 millimeters height, if you're making something really big coming out, then you get a point deducted. If they are not all matching up at each side, then you get a point deducted. If it's all just a giant mess and nothing adds up to nothing, then don't waste the time. So I'll show you now how to make it a simpler one. But this one is difficult, but it's kind of nice. It's actually very simple. Remember, this is very, very simple. If you're looking into this diagram, it's only 2 edges, 2 ridges, 3 valleys, equally spaced, happy days done. Let's make a simpler one, just because we can. So let's look at some I made before. Now this one is obviously ridiculously simple because it has just one valley, one ridge. It's round as well, that's easy. This one is interesting because it uses a off-centered element, and we could try to make that. Do you want to do that one? Should I show you this one? Who wants this one? No. This one we did just now, but let's do this again with one valley, one ridge, okay? So, I'll show you this here. So, at the moment, okay, we did this. So what we did is, we had ridge, 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 and we connected this, and we connected this. And then we did the same here, but here we connected this, and this, and this, and this. Now you can do the same design with one point. One point in the middle. Oh, that's interesting, but it's the worst. So, one over the edge, one over the field, one over the other one. That would be easy. You can do that as well with 3 points, but that goes crazy. That's fun. At the moment as well, one of the things that you might have noticed, we kept everything very flat. So, if you want to go really crazy, remember these at the moment are all flat. You see that? They're all on the same height. But if you want to, you could obviously make one of them higher or lower. Remember, this is the ceiling of our 50-50-50 block. So if I wanted to, so I'm making the ceiling here, so this is my ceiling. So if I take this green curve here, for instance, okay, and I would make this curve, see how I made it? It's very simple, blah, blah, blah. From this point to this point to this point, all very easy. Same what I did here. So, if I'm connecting now, I mean, it's not that easy, but it's actually quite simple. You have to basically push the curve up. So here you see the curve, right? And we use this line. So if I use this line and I build a line that is vertical from this point here where it meets the line to this element, this is our outside post here, then you can use the interpolated curve from this point to, let's say, half of this line to this line back. And what happens now, that's quite interesting, and then we could use the same one here that we used already. So, in this case, if I make the sweep to rail, I would use the green line here, and then my new line, which is 3-dimensional, not 2-dimensional, and then I can use the polysurface edge here. Actually, I would need to take this curve and explode it. And then remember, take my little rail curve here and join it, and my little rail curve here and join it. So this is the line, explode, and then I just take this curve and this curve, join. And then I can do the railing again, so I take now the black rail. Ooh, now look at that, I made a mistake. I was really dirty modeling here. See that? I made a big mistake. It's good that I saw this now. So you have to really pay attention where you are snapping to. So this really wants to be at the end here, to let's say near here, and then again to the end here. Otherwise, the whole thing will not work. So we really need to use the snaps. And now we can use the rail. So we use my new 3D curve with the old 2D curve, with the newly established little sweep curve, and the sweep curve here. And then, you see now, we would have created this which comes up. So that obviously means the other ones have to follow exactly that as well. So you can, I think it's okay if you do them flat, that's difficult enough. If you want to go crazy and have as well 3D curves, everything will become a lot more difficult. Because obviously the 3D curves mean that you have to use the other curves as well in 3D. So I would not recommend that if you don't feel safe, then don't do then keep them all on one level for now, and that will make it easier. You can play, of course, around with, for instance, the edge condition here, because at the moment we just use very straight lines, but you don't have to. Of course not. I mean, you could use, for instance, from here to the middle point of here, and then draw yourself a nice little parabolic surface like this, for instance. And like this. You only need to make sure that you always draw the same on both sides, right? Because then when you obviously can use these and use your rail curve around it. So I'll demonstrate this, and take this, and this, and this. So I'm copying this out just to demonstrate it to you guys. So here, if you're using this element here, and we can use another one here, it just needs to be the same. So, I mean, not the same around here, but the same around all sides. So yeah, let's use, for instance, this guy and this guy, join. And then we need to mirror this middle point. And our middle points are really your friends. Keep them nice. Then you can do your sweep to rails, one rail, two rail, one sweep curve, two sweep curve. What you get is obviously a more rounded version. Remember though what I just did here, on purpose I made a very bad mistake. You see this, what happens here? Who can tell me what's wrong with this? Yes, overhang. So the drill cannot reach it. So if you do play with that, play with it in a way that it makes sense so that it cannot go further than the middle of this line. So this, my guideline was more than the middle. So it means if I make this line perpendicular down here, then my line should never go over the perpendicular line. So I'm undoing this now, deleting this guy, and then I can use my little nice soft curve and do whatever I want here. So if I do it like this, then it will be fine because I'm not doing an overhang on undercut. Here you can mirror this again. Midpoint to midpoint, and then again use the sweep to rail, one rail, two rail, one sweep, two sweep, done. This one, easy peasy, producible. Of course you could go even crazier, for instance. Again, you could connect the two high points and use again a vertical component here and do the reverse. So if you hide that for a moment, we could use, for instance, a parabolic other way direction. So drawing this, explode, drawing this guy with this guy, and then mirror it. And then we can use our sweep to rail, as always, sweep one, sweep two, use this guy, and use this guy, and you will get the same, but now reversely, going inwards, outwards. Okay, so these are just different edge conditions. It will still be the same, all right? And then, of course, you would need to mirror this guy from here to there, and you would have to do the same what we did before, trim the excess elements in the middle off. So you end up with something like this. A little bit more complex than what we have here, but not too much more, because you still have the same condition as here. So these are just some playgrounds for you to play with, if you like, so to speak. Now, making an easier version, just because we're doing it, I'll do this for you now. And I'll do that quickly, I mean not too quickly, but so that you can have time enough for your exercise. So I copy now my hexagonal shapes out, and this I will make as a single point high point. So here you have my top 50 millimeters, my bottom. I keep this range of where I want to operate, and now I'm exploding this again. So I have single lines, and I want a single ridge, so I divide this by 2, means I get 1 point here, and then I can already basically go 1 point, 2 point, 3 point. So that was easy. And again, you can mirror this over the edges, or over the fields if you're smart, and you can make your life even faster. Okay, so now again we have to make a one field connection. Remember, we can do first a straight line, and that straight line will already help us to connect from here to the other end. So now we have a helper line that's at the right height. And with the helper line, I can use my round curve from this ridge to somewhere here to this ridge. Okay, got that one. Now we have to do the double field ridge line, a little bit more tricky. So we make ourselves a nice little help line from the midpoint here to the midpoint there. And then we have to make another of our interpolated point curves. This field to somewhere here, to the other field here. Done. And this guy we have to mirror along this line here. So now we got 1, 2, 3 ridges. I'm making them the highlights. So we got these ones done already. That was not too difficult, was it? And now we obviously we can start to disassemble them and cut them and work with them. This one we don't need to sweep anymore. So here we can take this line and split it with the other line. Remember to count your numbers. So here go explode. And if you have something with 4 lines, 1, 2, 3, 4, good. The only thing is this one we still need to split. 1, 2, 3, 4. Bob's your uncle. Surface on 3 edges, done. Next one. 1, 2, 3, 4. Easy peasy. Walk in the park. This one we need to explode before. 1, 2, 3, 4. Make the 4 curves. Done. Next one is this guy and this guy. So 1, most likely to explode against something. Yep, this one. So 1, 2, 3, 4. Done. We could have mirrored that as well, to be honest. Now we're going to go to this guy. So 1, 2, 3. So now we come to our special crazy cases. So here we have to go and think again a little bit. But again, we have our middle line. So if we want to be happy days, we take the middle line that we used and we split it with the surface of this line. And and then we have 1, 2, 3, 4. But this one will be not counted as one, so we join this, and then we do a split of this rail line, and this we have already, so now we can do a railing, 2 sweep lines, 1, 2, 2 sweeps here, 1, 2, done. Now this one we really can just mirror and be happy and done and go home. Endpoint, you are anywhere near the guy is okay. So now join all this up. That gives you one open poly surface. So we're getting there. Now we only need to build the side here. Again, we can trace it 1, 2, 3, 4, 5. Use C for closing. Take the curve, make the planar surface. Okay, done. Mirror one to the other. Always nice and snapping. If you don't snap, you lose. You snooze, you lose. You don't snap, you definitely lose. 1, 2, 3. And that you can mirror over the middle point. 4, 5, 6. The top part, join. Again, one open poly surface. As they are flat, you can try CA2 for capping. Boom, done. This is one closed object on a height 5 points, done. If you do 2 ridges and it all locks up, I give you an extra point. 2 ridges, you get 6 points out of a 5-point assignment. 1 ridge, everything lines up, everything works, you get 5 points. 1 ridge, or if you do 2 ridges with curved lines, if you do 2 ridges with curved outside with height difference, I give you 7 points. But again, if they don't line up and all that, you get deducted.